Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello students. Welcome to the period 2 of week 3 of our e-learning class. My name is Oladimiji T.A., the SS3 physics teacher of S3PHYWK3P2 Model College, Ibadan. In our last class, we started a topic titled Models of Atom. And we were able to look at two different models of atom. We looked at Thomson model of atom and Rutherford models of atom. Today, we want to look at another two models of atom. We will start with the Bohr model. Then after that, we will also look at electron cloud model. Let's start. The Bohr model. In 1930, Niels Erik Bohr modified Rutherford model of an atom by introducing the quantum idea in the atom. He published his new theory of the atom's constitution. And just like Rutherford, he assumed that electrons rotate around the nucleus. But Bohr had three completely new ideas. Let's look at these new ideas one after the other. Number one, there are some orbits called by him the stationary ones, where the moving electrons don't emit energy. What Bohr meant by this, number one, is that the orbit at which an electron will move without radiating energy is just that where its angular momentum is quantized. Number two, each emission or absorption of radiation represents the electrons transition from one stationary orbit to another. The radiation emitted during such transition is homogeneous and its frequency is given by the formula HF is equal to En minus EI, where H is the Planck constant. En and EI are the energies in the two stationary states. Let's also look at what he's saying in this second one. He said an electron will radiate energy if it jumps from higher orbital or energy level to a lower orbital or energy level. And the energy radiated is given by the equation HF is equal to En minus EI, where H is the Planck constant. En is the energy of the higher level and EI is the energy of the lower level. And the difference between the En and EI is the energy radiated. Number three, the laws of mechanics describe the dynamic equilibrium of electrons in stationary state, but do not describe the situation of the electron transition from one stationary orbit to another. Let's now think what each postulate means. The first one says that electron can move on unlimited orbit. That is, there is a limitation to how electron can move in its orbit around the nucleus. Only some orbits are permissible, and the only permissible orbits are the one in which the momentum of the electrons is quantized. So the postulate was in complete disagreement with other theories, and especially with the Maxwell theory of electromagnetism. Bohr formulated the postulate ad hoc. He didn't know what it might come out from, but he was of the opinion that to properly understand the nature of atom, one has to accept his idea. The second postulate says that in an atom, an electron can change orbit. On each orbit, the electron has some defined energy. So the energy of the electron is different on different orbits. So the bigger the orbit is, the bigger the energy. So if the electron change a higher orbit to a lower one, then it emits a quantum of energy. And if an element wants to go from a lower orbit to a higher one, it must absorb an adequate quantum of energy. The quantum of energy is proportional to the frequency of the emitted radiation as given in the equation stated above. The second postulate explains why the atom emits radiation of strictly defined wavelength. The third postulate is in complete disagreement with the classic theory. According to that postulate, the laws of mechanics can only describe electrons moving on stationary orbit and not while changing their orbits. The diagram below shows how quantum of energy is radiated or gained by an electron. In the first diagram, an electron absorbs a photon and jumps to a higher orbit from a lower one. As you can see, the red dot shows an electron and it accepts or absorbs a photon of energy, which is the yellow spiral or orange spiral, and it jumps from its lower energy to a higher energy as shown by the arrow. But in the second diagram, an electron, the red dot, at a higher energy level loses photon of energy, that is radiates a photon of energy, and it jumps from that higher energy level to a lower one because it has radiated energy. Now let's move to the electron cloud model. The model visualizes the atom as consisting of a tiny nucleus of radius of the order of 10 raised to power minus 15 meter. The electron is visualized as being in rapid motion within a relatively large region around the nucleus, but spending most of its time in certain high probability regions. Thus, the electron is not considered as a ball revolving around the nucleus, but as a particle or wave with a specified energy having only a certain probability of being in a given region in the space outside the nucleus. The electron is visualized as spread out around the nucleus in a sort of electron cloud. Some chemists prefer to consider the electron in terms of a cloud of negative charges, that is, electron cloud, with a cloud being dense in regions of high electron probability and more diffuse in regions of low probability. This model is known as the electron cloud model. Most of the time, but not always, the electron will be located inside the spherical outline. In other words, the probability of finding an electron inside the spherical bonding is high. The probability then decreases rapidly as the distance of the thin shell from the nucleus increases. This is what electron cloud is all about. Schrödinger and S3PHYWK3P2 in 1925 independently developed a new mechanics called wave mechanics. In the new mechanics, an electron is treated as both a particle and a wave, moving at some distance from the nucleus and with definite energy. Electron could be found anywhere, but there are more chances that it could be found near the nucleus. That is, the exact position of the electron cannot be predicted, as it does not move on a fixed orbit as proposed by Bohr. The electron cloud model sees an atom as having a tiny nucleus of radius of approximately 10 raised to power minus 15 meter, with the electrons moving around it. The electrons spend most of its time in the high density region where they are likely to be found than in the low density region. That is all what electron cloud model is all about. So far so good. We are able to look at the Thompson model, the Rutherford model, the Bohr model, and the electron cloud model. And this is where we are going to end it for this second period. Until next period when I will come your way again, my name is Oladimeji T.A., the SS3 physics teacher. I'm saying again, Assalamu alaikum wa rahmatullahi wa barakatuh.